Hello Senior 2, how are you all? Today I'll talk about the last one in the quantum number and the distributing of the electrons. The last one is the spin quantum number and its sample ms. Each electron in any orbital spin around its own axis. The spin of the electron may be clockwise or counterclockwise or anti-clockwise. If the spin motion clockwise, the arrow was in the top, and the spinning of the electron is anti-clockwise, that's the arrow of the electron in the bottom. Principles of distributing electrons. We have three principles: Paul's, Aufbau, and Horn's rule. First, Paul's exclusion principle. It's impossible for two electrons in the same atom to have the same four quantum numbers. As we know, we have n, l, ml, and ms quantum numbers. If the first electrons n equal 3, l equal 0, ml equal 0, ms is clockwise plus half. The second electron must be n 3, 0, 0, negative half. It's impossible to find two electrons in the same atom to have the same four quantum numbers. Number 2, Aufbau or building up principle. We must occupy the electrons in the sublevels in the order of increasing the energy from the lowest energy sublevels are filled first. Arrangement of the sublevels according to the summation of n plus l. Example, the energy of 4s is lower than the energy of 3d because the summation of n plus l of 4s is less than the summation of nl of 3d. The n of 4s equal 4, the l equal n minus 1, so the summation of n plus l of 4s is less than the summation of n plus l for 3d. The sequence of energy sublevels ascendingly according to the energy of Aufbau. ss fast بس دبس دبس فدبس فدب. So 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7b. It's called ss بس بس دبس دبس فدبس فدب. S, it just contains one orbital, and we have the relation between the orbitals and the electron capacity. P has 3 orbitals, D 5 orbitals, F 7 orbitals. The relation between the orbitals and the number of electron capacity is the orbital times 2 equal the electron capacity. S have just one orbital, so the electron capacity 1 times 2, so S contains 2 electrons. LP has 3 orbitals, so the number of electron capacity equals 6. D have 5 orbitals, so the number of electrons equal 10. F contains 7 orbitals, so the electron capacity equal 14 electrons. Okay, question. Write the electron configuration for the following elements according to the Aufbau building up. Na, as we know, the atomic number of Na equal 11. So 1s2, 2s2, 2p6. Summation the number of electrons, 2 plus 2 plus 6, so we have 10 electrons. And the rest of the atomic number of sodium 1, so 3s1. Calcium 20, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Zinc 30, 1s2, 2s2, 2p6, 3s2, 3cp6, 4s2, 3d10. Number 3. Horn's rule. No electrons pairing takes place in a given sublevel until each orbital contains one electron. We have some rules of filling of energy sublevels according to Hund's rule. Number 1. The orbitals of the same sublevels are equal in their energy, like 2p, 2px, y, z have same or equal in the energy. Number 2. The orbitals of the same sublevels are filled by unpaired electron first, like 2b. If they are 2b2, not filling the two electrons of p and px. No, we fill one electron in px and the other electron in py. The spin of single electron, because the spin of single electron in the same direction gives the atoms more stability. Number 3. When two electrons are paired in one orbital, they have opposite spin, because if they are in the same direction, they have a law of repulsion force. So when two electrons are paired in one orbital, they must be in opposite spin or in opposite direction to decrease the repulsion force between them.